hold on!
Hey there guys, what's going on and welcome back to our channel. Who makes the safest cars on the planet? Tesla, that's who, and that's not an exaggeration. It's a fact rarely acknowledged by the media. Meanwhile, Tesla is redefining vehicle safety standards, and they've achieved this audacious goal by bringing together industry-leading design, engineering, and software. Tesla is accelerating the world's transition to sustainable energy with electric cars, solar panels, and integrated renewable energy solutions for homes and businesses. Tesla's journey started back in 2003, so let's head on to how Tesla has the highest safety ratings. The Palo Alto-based company is the top-rated EV company in the world today and is arguably the biggest EV player right now. The Musk-led company fought all the odds and didn't get steamrolled by the other automakers. Tesla Motors' goal is to accelerate the world's transition to sustainable transport with a full range of increasingly affordable electric vehicles. California-based Tesla designs and manufactures EVs as well as EV powertrain components for partners such as Toyota and Mercedes. Independent testing by the National Highway Traffic Safety Administration has awarded the Tesla Model S a 5-star safety rating, not just overall, but in every subcategory without exception.
Enormous electric motors send nearly 800 brake horsepower to all four wheels.
Approximately 1% of all cars tested by the federal government achieve 5 stars across the board. NHTSA doesn't publish a star rating above 5. However, safety levels better than 5 stars are captured in the overall vehicle safety score provided to manufacturers, where the Model S achieved a new combination record of 5.4 stars. Of all vehicles tested, including every major make and model approved for sale in the United States, the Model S set a new record for the lowest likelihood of injury to occupants. While the Model S is a sedan, it also exceeded the safety score of all SUVs and minivans. This score takes into account the probability of injury from front, side, rear, and rollover accidents. The Model S has the advantage in the front of not having a large gasoline engine block, thus creating a much larger crumple zone to absorb a high-speed impact. This is fundamentally a force over distance problem. The larger the crumple zone, the more time there is to slow down occupants at G-loads that don't cause injuries. Just like jumping into a pool of water from a tall height, it's better to have the pool be deep and not contain any rocks. The Model S motor is only about a foot in diameter and is mounted close to the rear axle, and the front section that would normally contain a gasoline engine is used for a second trunk. For the side pole intrusion test, considered one of the most difficult to pass, the Model S was the only car in the good category among the other top 1% of vehicles tested. Compared to the Volvo S60, which is also a 5-star rated in all categories, the Model S preserves 63.5% of the driver residual space versus 7.8% for the Volvo. Tesla achieved this outcome by nesting multiple deep aluminum extrusions in the side rail of the car that absorbed the impact energy. A similar approach was used by the Apollo lunar lander and transferred the load to the rest of the vehicle. This causes the pole to be either sheared off or to stop the car before the pole hits an occupant. The rear crash testing was particularly important given the optional third-row children's seat. For this, the Tesla factory installs a double bumper if the third row seat is ordered. This was needed to protect against a highway speed impact in the rear with no permanently disabling injury to the third row occupants. The third row is already the safest location in the car for frontal or side injuries. The Model S was also substantially better in rollover risk, with the other top vehicles being approximately 50% worse. During testing at an independent facility, the Model S refused to turn over via the normal methods, and special means were needed to induce the car to roll. The reason for such a good outcome is that the battery pack is mounted below the floor pan, providing a very low center of gravity, which simultaneously ensures exceptional handling and safety. Of note, during validation of Model S roof crush protection at an independent commercial facility, the testing machine failed at just about 4 Gs. While the exact number is uncertain due to the Model S breaking the testing machine, what this means is that at least 4 additional fully loaded Model S vehicles could be placed on top of an owner's car without the roof caving in. This is achieved primarily through a center beam pillar reinforcement attached via aerospace-grade bolts. It's possible to gain the regulatory testing score to some degree by strengthening a car at the exact locations used by the regulatory testing machines. After verifying through internal testing that the Model S would achieve an NHTSA 5-star rating, Tesla then analyzed the Model S to determine the weakest points in the car and retested at those locations until the car achieved 5 stars, no matter how the test equipment was configured. The Model S lithium-ion battery did not catch fire at any time before, during, or after the NHTSA testing. It's worth mentioning that no production Tesla lithium-ion battery has ever caught fire in the Model S or Roadster despite several high-speed impacts. While this is statistically unlikely to remain the case long-term, Tesla is unaware of any Model S or Roadster occupant facilities in any other car. Also, the airbags used in Tesla vehicles are specially designed for maximum safety and work in combination with the sensors installed in both the driver and passenger seats to determine the size of the seat occupant and inflate only to the extent required.
Whoa, bro. Oh my god. I can't believe it.
Other manufacturers simply order airbags from a third party and just install them in their cars to fulfill basic safety requirements. As such, we've witnessed recent recalls due to injuries and deaths related to faulty airbags and airbag systems. Tesla's vehicles exhibit exceptional safety in a side impact or intrusion incident, as a rigid battery pack plays a pivotal role in stopping the colliding object from entering the cabin in a manner that's too deep to be considered safe. This also makes the Tesla side airbags perform better than an ICE car, giving them more time and space to save the occupants. It's worth noting that all Tesla vehicles come with a great set of safety features right out of the box, even if you don't opt in for Enhanced Autopilot (EAP) at the time of your Tesla purchase. Following are safety features that come standard on any Tesla vehicle: full LED exterior lighting, 8 cameras, forward radar, and 12 ultrasonic sensors, enabling active safety technologies including collision avoidance and automatic emergency braking. There are also 6 front row and 2 side curtain airbags. So do give us your thought on all of these safety features in the comments section below, and whether you think they're just about right or they're a bit of an overkill. And while you're doing that, don't forget to hit that like button and subscribe to our channel so you can catch up on more Tesla content in the future.